Okay, these actually are polygons. Okay, that's the more technical term than just shapes. And they actually happen to be special polygons. These are actually regular polygons because their angle measures and their sides have the same length. Okay? And the sides have the same length and the angles have the same measures. Now, I want to talk to you about the sum of the angles and the number of sides. Okay, so how many sides does a triangle have? All right, that's the minimum number of sides you can have and be a polygon. You can't make a two-sided polygon because it has to be a closed figure. All right, so this has 3 sides. Now, how many triangles are there? Well, there's 1 triangle. Okay, what is the sum of the angles of the in the inside of a triangle? Oops, I just messed up here. Sum of angles. You do not need to write this down. Again, I'm just showing you. So this would be 180 degrees, right? We remember that? Okay, now, if I go from one vertex to, well, let me just say it a different way. How many triangles minimum can I divide this figure into? Yes. By making a diagonal that way. So what I see here now are, this thing has sides of 4. There are 4 sides, and there's 2 triangles. Okay. The sum of the angles is 180 plus 180, which is 360. This has the number of sides of 5. I know that's a weird way to say it, but that's how I'm writing it. So let's see what we got here. Oops, I just want a segment tool. How many triangles can I split this up into? You only come from one vertex, the minimum number of triangles. I can make more triangles. So I'm not saying that I can't, but I want the minimum number of triangles coming from one vertex. There's 3 of them. So what were we going to say, Bryson? 3 times 180, what's that? That's how much the angles of that 540 degrees. Okay, this one, how many minimum number of triangles I can make? All right, the number of sides is 6. I can make 4 triangles out of that. That's the minimum number. So the sides were 6 and the triangles are 4 triangles. And this one was 3 triangles. And this one has 7 sides. And I'm just going to draw these kind of ugly now because that's how you would draw. There's 5 triangles. How many sides? There are 5 sides and 7 sides and 5 triangles. And this finally is an octagon. The number of sides is 8. How many triangles are you going to guess? How are you getting that? 6. There's a pattern. That's what we're looking for. We're looking for a pattern. Okay, so I want some help with a pattern for how I'm going to get these numbers. What's 4 times 180? That would be the angle measures of that one. 720. So we're adding on a triangle every time, right? But I don't want to work with just adding on because that will be much harder if I say, well, how much do the angles add up to in a 20-sided figure? You know, do you want to have to count and add up 180 every time? No, pain in the neck. So you want a formula. That's what we're developing. All right, we're figuring out the formula that tells us how to figure out what the angles are in any polygon with n number of sides. Okay, so n being the number of sides. How does the number of sides and the triangles formed compare? All right, say that loud, Bryson. You subtract 2 from the number of sides, n minus 2. Okay, and then what are you going to do to that to get the total? What were we doing every time? By 180. Okay, that is the formula for the sum of the interior angles of a polygon, period, given the number of sides. Okay, so we figured out the formula. We don't have to write anything down yet. We're going to write it all down in our ISN in a minute. Okay, I just want you observing right now and just trying to understand where I'm getting these ideas from. Okay, so now I'm going to go really fast, and I'm going to make this thing magically erase everything. And then I'm going to talk about something else, which is what we're going to start with in our ISN. Okay, so I'm going to do something different now. Now I'm going to talk about not the inside angles. I'm going to talk about some exterior angles. Remember how we extended a side and we had, oh, this exterior angle is equal to the addition of those two? Well, that's not the theorem I'm looking at right now. So I'm going to extend these sides. Now I want to see if you start to see a shape, something that you might relate to these drawings. Oh. What happened to my octagon? I went back too far. That's okay, I don't need it. We got enough. Okay, so here's what I want to propose to you. We learned last semester that if you have an equilateral triangle, then it is equiangular as well. How big were the three angles each? Okay. We also learned that if you have two angles that are adjacent forming a straight line, then they form a linear pair. How big's the angle out here? 120, because these two must add up to 180. Okay, so then there'd be a 120 there and a 120 there. All right, what are these three outside called exterior angles add up to? Okay, so the exterior angles sum for these figures is 360. Okay, what are the angles in a square? The corner angles, these 90. So what's this one out here? 180 minus 90 is? Okay, so these are 90. How many are there? You're only allowed to go in the same direction around like that. These are each 90, so there's 4 of those. What's 4 times 90? Okay, I'll let you know that these angles are 108, which makes the angles on the outside 72. How many are there? 5. What's 5 times 72? Ooh, 360. These are 120. And we're going to learn how to figure that out too. If those are 120, these exterior ones are 60. And there's 6 of them. 6 times 60 is? It's always true. That's always the case. All right, so in your ISN, please look at the top page for a moment. Oh, I was in the ISN, dummy. I'm talking to myself. I'm not talking to you guys. It's me. All right, this is the page. I forgot I was already on the ISN thing. This is the front page. This is the main thing that their chapter is going to be about. It's going to be about the quads. All of these are quadrilaterals. All right, and we're going to learn all kinds of stuff about all of these shapes in this chapter. But for right now, we're talking about other shapes that aren't just four-sided. We're talking about things that have more angles than that. Okay, so on the second page, or the page, flip it, get your ISN opened up. You got interior angles, of course, on the inside of the figure. And then out here is an exterior angle, which is what I just illustrated to you. What we just found out is that the sum of the exterior angles of a convex polygon is always how much? 360. I kind of yelled. My recording will have a yell in it. Oh well. No matter how many sides or angles the polygon has. Okay, each exterior angle of a regular polygon. What's regular mean? All angles congruent and all sides congruent. Okay, if you know it's a regular polygon, you can take 360 degrees and divide it by the number of sides. And that's going to tell you how big each of those exterior angles are. So here's the deal. I'm going to go ahead and draw on this one. I'm going to extend these sides. Okay, and I'll let you know that, hey, remember that number of sides was 5. 5 minus 2 was 3. 3 times 180 was 540. So each interior angle, each interior angle is 540 divided by 5, which is 108 degrees. So that tells me, wait a minute, I didn't have to do that. I actually could have found an exterior angle. You can do 360 divided by 5, and that tells you that each exterior angle is 72 degrees. Does that go with the 108? Yeah, because these should add up to 180. They're supplementary. So all of these angles on the exterior are 72 degrees, and all of the angles on the interior are 108. Does anybody still need this? I can wait. Okay. All right. Can we go now? What do you have? What? No. He had it early out. Okay, next. Here's this chart. We've already done a lot of this, so I'm going to go pretty fast through this, okay? This is what I developed with you instead of us just filling this in and me telling you the answers. All right, the smallest number of sides a polygon can have and be a polygon is, okay, and it's called a triangle. And the number of triangles formed is 1. And the sum of the interior angle measures we already learned is 180. The sum, okay? Careful. That's really one of the biggest kind of mistakes in the quizzes and tests in this unit, is not reading it. It says you want the total, okay? Not just each, okay? All right, the next number of sides, of course, would be 4. We're going to increase these by 1. So we're going to do 3, 4, 5, 6, 7, 8, 9, and 10, and then stop. Okay, the 4-sided figure, I don't want to call it a square. Yes, with a Q. You want to do it, name it by the number 4, which would be quadrilateral. Quadrilateral. The number of triangles formed was 2, and the sum of the interior angles was 360. The 5-sided figure, what's the name? Yeah, pentagon. You do need to know these. The number of triangles we formed when we did that one diagonal thing was 3, and the sum of the angles is 540. Now, where am I getting that 540? Here, I'll remind you. 2 times 180 was how I got 360. 3 times 180 is how I got 540. The 6-sided figure is called a hexagon. Excuse me. 4 triangles were formed when we drew it. So we're going to do 4 times 180 to get the sum of its interior angles, which is 720. Hey, remember the name for 7? Yes, say that louder. Heptagon. The number of triangles formed is 5. 5 times 180 is the sum of its interior angles, which is 900 degrees. 8 sides, we all know that one, I hope. Octagon, because of octopus. 6 side triangles formed. 6 times 180 gives me 1080. 1080 degrees. And I'm just curious. Anybody remember 9 sides? Nana. Nana gone. 7 triangles formed. 7 times 180. I forgot. Is that 1,260? 1260, right? Yeah. Oh my goodness, my pen's stuck. It's not moving. Okay, it's twitching. All right, come here. Yeah, it's 1260. I have got this thing's got to stop spasming. I'm not kidding. It's doing very. All right, I'm turning it off. Turn it back on. Just had to do that with my phone today. All right. All of a sudden, I couldn't see any place to send a note to my daughter. I don't know what's going on. Oh, I have to turn it back on. That would be helpful. All right. All right, 1260. Ooh, didn't mean for that to happen. Gotta grab a pen. All right, I'm back. Sorry. And you guys know 10-sided was decagon. Okay, and it would form 8 triangles. 8 times 180 is 1,440. All right, now we're going to do a generalization. Here's where we're going to put our formula. We did talk about 11-sided figure is undecagon and 12 dodecagon, but I expected you to know dodecagon. So n sides I want now. Anything beyond 12 we called an n-gon. The number of triangles formed would be number of sides, come on, minus 2. All right, so here's our formula, and I'm going to write it 2 ways. It's number of sides minus 2 in parentheses times 180, or I like to do 180 times n minus 2. Okay, so let's do a couple of examples. If a polygon is regular, then all the sides and all the angles are congruent. You must know what regular means. So, the measure of each interior angle of a regular polygon is 180 times the number of sides minus 2. So first you've got to do 180 times n minus 2. I'm abbreviating it. And then divide by the number of sides n. This is just the same thing. This one's in words. This one's more in formula notation. You need to pay attention to whether it's asking you for the sum. If it says sum, then you're just doing the 180 times n minus 2. This is called the polygon angle sum theorem. No, not in this unit. No, we aren't going to have proofs. I don't remember. Well, not too many of them. Not many this semester. A convex polygon has 13 sides. Find the sum of the measures of the interior angle. So that gives us an n of 13. We're going to plug it in the formula. We're going to do 13 minus 2 times 180, which of course is 11 times 180, and I do not know what that is off the top of my head. How many? 1,980 degrees total. Thank you. Second example, find the measure of each interior angle of a regular decagon. Decagons have a number of sides is 10. Okay. The sum first you need to find. So first you do the sum formula. And you do 180 times 10 minus 2, which is 180 times 8, and that's 1,440 degrees. If you want to know how big each angle is, next you will divide that sum of 1440 by the number of angles or sides, which is 10. 1440 divided by 10 gives us each angle is 144 degrees. I believe that's the last thing on the page, correct? Okay, so now we're jumping to the packet, which is where the work and assignment is. Angles and polygons. There are parts of this that are going to be repetitive, so we'll go kind of quickly in the beginning. Not watching that. That's something that I don't need anymore. All right, the majority of Chapter 6 is dedicated to properties of quadrilaterals, which are four-sided polygons. Today, though, we're concentrating on properties of any polygon. These are the quads we'll be studying. Aren't they cute? Remember, polygons are two-dimensional shapes made from line segments forming a closed figure. Polygons can be convex or concave. We're going to focus on convex polygons. Remember, this is concave, these are convex. Tented in, concave. That's not the formal definition, but that's the one we remember. Regular polygon, this is what you got to fill in. A regular polygon is a quadrilateral, is a polygon that is equilateral, meaning equal sides. I'm sorry? Yes, it goes on your, yes ma'am, on that sheet. The first blank that you have on your packet. We're done with the big packet. That's like the note, and you get to use those on your quizzes, those packets, the notes. All right, so equilateral means equal sides, equal angle means equal angles. All the sides and angles are congruent. Oh, did anybody still need to fill those words in there? Okay. Polygon interior angles sum theorem. The segments that connect the non-consecutive vertices. All that means is if you go to the next vertex, you'd get a side. So what they do say is go from that point to one here. This, oh, hello. I need to get a pen. From here to here, that's connecting two non-consecutive vertices. Consecutive means one after the other. You wouldn't want to connect that. It's not going to make a diagonal. The thing that we're trying to find is these are called diagonals. Okay. Draw all the diagonals from vertex A in each polygon. So we're only going from one vertex. This is basically what I did to illustrate the formula with you guys. So I did this one, and that gives me 3 triangles. And we had 5 sides. So basically this is the same idea as what I did a little bit ago. From A to the first non-consecutive vertex will be there. I could draw from A to here, and from A to here, and I got 6 sides, and I found out there were 4 triangles. If I go from A to all the vertices that make a diagonal, I have slow motion. There we go. Oh, it's much better when I do it with the segment tool. I gotta curve that one. Okay, this figure had 1, 2, 3, 4, 5, 6, 7 sides and 5 triangles. And the last one, 3, 4, 5, 6. This had 8 sides and 6 triangles. So the burning question was, how many triangles were formed compared to the number of sides? It was number of sides minus 2. It doesn't, does it on your paper? Don't worry about it. As long as you understand it, you know, that's okay. I just asked the question. We were developing the formula. So, oh, and I don't know why that's still here. I thought I deleted this. Oh, why is it? Delete the whole thing. Oh, well, I'll just leave it there. Okay, drawing all the diagonals from one vertex of an n-gon separates the polygon into n minus 2 triangles. That's what we were discovering, okay? Some of the measures of the interior angles of the polygon can be found by adding the measures of the interior angles of those n minus 2 triangles. So I'm ignoring that. Don't pay attention to that. You see the box, we have the formula, we already developed the formula, and we already put it in our ISM. N minus 2 times 180. Okay, then we already did all this work, and we filled it in our ISM. And then I thought, oh, I don't think this one isn't so cool, so I'll skip over that one. Let's do some problems, and then I do have one I do want to show you once I get to the exterior angle thing. Find the sum of the measures of the interior angles of each convex polygon. We are going to be using the formula 180 times n minus 2, or you can have that reversed. The n value for a decagon is 10, so we're going to do 180 times 10 minus 2. You don't have to write all this. Most of the time, you're going to be just using that calculator to do it. So you're going to be typing 180 times 8, because I'm sure you guys can subtract 2 from 10 in your head, right? Okay. You should be getting 1,440 degrees. Okay, all they wanted was the sum. They didn't ask for each. You want to pay attention carefully to what you're being asked to find. 30. That's n is 30, of course. 180 times 30 minus 2. You're probably just going to type 180 times 28. I have no idea what that is. It's big. I mean, I could probably estimate it, but 50 what? Thank you. I knew it was a little over 5,000, but okay, the 12 gun, 180 times 12 minus 2, which would end up us doing 180 times 10, and that's 1,880. That's an easy one. Why do I have 1880? I don't know where the 80 came from. The last 80. It's 1,800, right? And finally, the 16 gun. Oh, not finally. We actually have 2 more after this, I think. 16 minus 2. What's 180 times 14, people? 2,520. I find that people who just practice this, you don't understand. I think maybe you might not understand that actually doing the typing on the calculator and participating as we go, for some students, that gives you more of a physical memory of what to do. If you're that kind of learner, doing it means helps you learn it. So, and some people don't need to watch, and some people need to write later than after I write. So, I understand that. Octagon, n is 8, so we're going to do 180 times 8 minus 2. How big? 6? 1080? Okay. And then you guys, oh my gosh, this is going to be a big one. 35 minus 2. We're going to do 180 times 33. Almost 6,000, 5,940. Thank you. Okay. Here's an example of what we're going to do algebraically with this information. First, if we want to find x, we need to know how much the angles add up to. This has 4 sides. So the sum of the angles, 180 times 4 minus 2, which is 180 times 2, and that's 360 degrees. Okay, there's your easy part. Now, we need to take all this algebra stuff and put it all together and set it equal to 360. So let's put our x's together. I don't feel like writing that whole big string of stuff, so I might as well just add up my x's. 2, 4, 5, 6. Add up my numbers. I'm going to go 16 plus, wait, I'm going to change color for that. 16 and 14 makes 30, and I got 30 plus 30, so I got 60. 6x plus 60 equals 360 degrees. Okay, now we're going to subtract 60 from both sides. We get 6 times x is 300, and then you know we better divide by 6 and get x is 50. All right, now, we weren't asked simply to find x. It said also to find the measure of each interior angle. Well, let's do S and T, because the measure of angle S is something, and it's equal to the measure of angle t. They're both the same because they have the same expressions on them. So we only have two calculations to do. So 2 times 50 plus 16, that's 100 plus 16, 116. So S and T are both 116. We're good? Did I go too fast on that concept? Okay, and then pretty easy to get the measure of angle U and W because they're the same. And we're going to put in 50 plus 14 is 64 apiece. Okay. Anybody still need this? All right, we get to move on to number 8. This figure is not the same as the last figure, so the angles don't add up to the same amount. We got to figure it out. It has 1, 2, 3, 4, 5 sides. So the sum of the angles, 180 times 5 minus 2, that's 180 times 3, which is 540 degrees. Now notice these figures are not regular, okay? So each of these angles is probably different, okay? If it's regular, then we can just divide by the number of sides and get 108, but that's not the case here. So we got to add up all this x stuff. So I'm going to do 7x plus 4x plus 5x plus 6x plus 4x. What do we got? 26? Okay, 26x. Then, plus 5 minus 5. We're back to 0. And then we've got 10 and 10, so that's 20. And the total is 540. All right, we'll subtract 20 from both sides. And then we got to figure out what 520 divided by 26 is. I got 20. Okay. Now we're going to pop them back in. So here we go. We got a bunch of angles. We got 5 angles to write down. I'm going to start, I don't know why, but I like starting on the left. I'm going to start with E. It doesn't matter what order. Measure of angle E, we're going to find the measure of angle D, etc. E would be 7 times 20. You could do probably that in your head. 140. 4 times 20 plus 5, that's 85 for angle D. Measure of angle C is next, at least for me. 5 times 20 minus 5, 95. And then measure angle B, 6 times 20 plus 10, 120, 130. And last but not least, the measure of angle A, 4 times 20 plus 10 is 90. A lot of answers to that question. You need to show X, and you need to show how big each angle is. Okay, this is where I wanted to show you something kind of cool. We decided already that these angles on the outside of a polygon, if you were to extend the side, even if it's irregular, they're always going to add up to 360. Okay, now I'm going to show you something why, or a visual of that happening. Okay, so I'm at a website here. This is 30, the exterior angle is 150 because these add up to 180. Likewise, in a polygon, if you extend a side, you know this angle, you can find the other one by the fact that they're a linear pair. But here's something I want to show you. This is a really nice picture of our exterior angles. And why did they add up to 360? If you start spinning this around, anybody, what does that remind you of as when you were a kid, maybe? If you spin that? Do you remember? I remember pinwheel. Yep. That's what I was looking for. If anybody remembers what a pinwheel is. All right, watch this now. So if you take one of those exterior angles and you just converge them together, do you see that they gave you a circle? And how many degrees is in anything that has a center all the way around? That's 360 degrees. So those angles, there's your proof that they're going to add up to 360. Okay? Kind of neat picture, I thought. I got to do it one more time. All right. So the angle measures add up to 360, and that's all I want to show on this because we're running low on time for that. Okay, find the sum of the measures of the exterior angles, one at each vertex of a convex 27gon. All right, for any convex polygon, who cares how many sides it has? The answer is always the same. It's the exterior angles. If it says that, it's 360 degrees. Oh, flipping the page, please. You're going to get, or are you flipping already? Not yet? Okay, find the measure of each exterior angle of a regular hexagon. It has to be regular for them all to be the same. So the sum of the measures of the exterior angles was 360, and a hexagon has 6 angles. So 360 divided by 6 is how I would do it. Or you can say 6 times the number of the measure of the angles is 360s. I don't like that they're using n. All I want you to know is the measure of each is 60 degrees. I don't like that they're using n here because we were using n for the number of sides, okay? And it is the same, no, it's not the same. So, find the sum. Okay, if we're going to find the sum of the exterior angles, we have to even read the question of what it is, the shape. You don't, because it's exteriors. Its exteriors is always, yeah, 360. So, boom, boom, we just write 360 for every one of those answers. 9, 10, 11, each 360. All right, this is important. The measurement, what's the relationship between the measure of the exterior angle and the interior angle? They are supplementary. Oh, my pen just froze. The word I was writing is coming. Supplementary. They're a linear pair. Okay, so when given the interior angle, find the exterior angle. So if you know the interior, to get the exterior angle, you'll do 180 minus the interior angle. That's going to equal the exterior angle. You can do that backwards too, and use the fact that the sum of the exteriors is 360 to find the number of sides. So if you take 360 and you divide that by the measure of an exterior angle, then you're going to get the number of angles, which is the number of sides. Ready? Find the measure of an interior angle of a regular polygon. Oh, no, it says that the measure of an interior angle is given. Find the number of sides. Okay, first, I have this is an interior angle. So the exterior angle would equal 180 minus 165, which is 15 degrees. All right, now to get the number of sides, we're going to take 360 divided by 15, and then we'll get the number of sides. I don't know, for 24, right? So that means we have 24 sides for that polygon whose interior angle is 165. Okay, so if the interior is 144, that's your interior angle. Therefore, the exterior angle is 180 minus 144, which is 36 degrees. If you want to know the number of sides, if you want to write a formula, I'll show it. Number of sides would equal 360 divided by 36, and that's 10. So this would have 10 sides. Okay, let's do the last two here, and then I would like you to spend some time on questions in the packet. We're basically got the information we need. What's an exterior angle if the interior is 135? 45? Okay, 360 divided by 45 is 8. Okay, so the figure has 8 sides. And if an interior is 160, the exterior angle would be 20. 360 divided by 20 tells me this thing has 18 sides. All right, do spend some time looking at these. And if you have questions, of course, I want you to come prepared with those Monday. Oh, sorry. Well, might not be Monday if someone's listening to this later, but anyway. Next time we see one another. Timer, time out.